Hello and welcome to Electro Nerds Academy. In today's video, we'll be interfacing the HC-SR501 PIR sensor with an Arduino. PIR stands for Passive Infrared Sensor. All objects, including the human body, emit heat energy in the form of infrared radiation. The hotter an object is, the more radiation it emits. This radiation is not visible to the human eye because it is emitted at infrared wavelengths. The PIR sensor detects movement by measuring this infrared light radiating from objects in its field of view. The sensor's output goes high if a human or animal moves within its range, and it remains low when no motion is detected. Here's what our sensor module looks like from the top. This module consumes less than 2 milliamps of current and can detect motion up to 7 meters, or 21 feet, with sensitivity control. If we remove the plastic dome from the top, we can see the main sensor. The IR sensor itself is housed in a hermetically sealed metal can, which protects it from noise, temperature, and humidity. This sensor consists of a window that allows infrared radiation to pass through. The window is made of an IR transmissive material, typically coated silicon, that protects the sensing element. Underneath the metal can, there are two separate pyroelectric sensing elements, one responsible for producing a positive output and the other for producing a negative output. When there is no movement, both elements detect the same amount of IR radiation, which is the ambient radiation from the room, walls, or outdoors, resulting in no voltage output. When a warm body like a human or animal passes by, it first intercepts one half of the PIR sensor, causing a positive differential change between the two halves. When the warm body intercepts the other half of the sensor while leaving the sensing area, the reverse happens. The second element generates a negative differential change. By reading this change in voltage, motion is detected. Currently, the detection area consists of two rectangles. Ideally, we'd like a larger detection area, but we don't want to increase the size of these rectangles because the moving object should cross both sensing elements for the module to detect motion. If we make these rectangles large, the object might be in the range of one sensor but not the second. Instead, we need multiple small rectangles scattered throughout the complete range. For this, we use the plastic dome we removed earlier. If we look at the inner side of this dome, we can see multiple sections, each with concentric grooves. Each section acts as a Fresnel lens. A Fresnel lens is a type of compact lens designed to condense light, increasing the module's range. These lenses create a range of detection areas interleaved with each other. Note that the lens centers in each section are inconsistent because each one points to a different half of the PIR sensor. In addition to the PIR sensor, the HC-SR501 module houses a PIR controller IC, the BIS0001. This chip processes the output from the pyroelectric sensor and emits a digital output pulse. The module includes a 3.3 volts precision voltage regulator, allowing it to be powered by any DC voltage from 4.5 to 12 volts, although 5 volts is commonly used. It also features a protection diode, or safety diode, to prevent damage from reverse voltage and current, safeguarding the module if the power is accidentally connected with incorrect polarity. The PIR sensor has a potentiometer on the back to adjust sensitivity, setting the maximum detection range between approximately 3 meters to 7 meters, 9 to 21 feet. Rotating the pot clockwise increases sensitivity and range, while rotating it counterclockwise decreases them. Another potentiometer adjusts the time delay, determining how long the output remains high after motion is detected, with a range from 1 second to about 3 minutes. Clockwise rotation increases the delay, and counterclockwise rotation decreases it. Additionally, the module has a trigger selection jumper for choosing between two modes. Some modules have a solder bridge jumper instead. Connecting the center pin and the pin labeled L selects the single trigger mode. In this mode, the output goes high when motion is detected and stays high for the duration set by the time delay potentiometer. Further detection is blocked until the output returns to low after the delay, followed by a 2-second lockout period. Connecting the center pin and the pin labeled H selects the multiple trigger mode. Here, the output goes high when motion is detected and stays high for the time delay duration. Unlike single trigger mode, further detection resets the time delay, and the output only returns to low after the delay once motion stops. The module also allows for soldering a thermistor, temperature-sensitive resistor, where labeled RT for extreme temperature operation, or an LDR, light-dependent resistor, where labeled RL for dark operation. Now let's apply what we've learned by creating a project to control a room light bulb using motion detection. First, connect the relay module to the Arduino. The connections are straightforward. Connect the 5 volts and GND pins on the module to the corresponding pins on the Arduino, and connect a digital pin, we'll use pin 5, to control the relay module. Next, connect a regular household bulb to the relay module. Exercise caution as we're dealing with high voltages. Connect the phase wire from an electrical outlet to the common terminal on the relay module. Connect one end of the bulb to the normally open terminal and connect the neutral wire directly to the bulb. Now, connect the sensor to the Arduino by connecting VCC to the Arduino's 5-volt pin, GND to the Arduino's ground pin, and output to one of the Arduino's digital input pins. We'll use digital pin 4. Set the HC-SR501 jumper to the H, multiple trigger mode. Position and turn the time delay potentiometer fully counterclockwise to set it to at least 3 seconds. Adjust the sensitivity potentiometer to your desired level or set it to the midpoint if you're unsure. Next, let's program the Arduino. Begin by declaring 2 integer variables, relay and sensor, to hold the pin numbers for the relay and the module, and another named value set to 0. In the setup function, set the relay pin as an output, the sensor pin as an input, and pin 13 as an output. Add a 40-second delay for the HC-SR501 to calibrate to the environment. Ensure minimal movement in front of the sensor during calibration. After calibration, turn on the onboard LED on pin 13 to indicate readiness. In the loop function, read the digital value on the sensor pin into the value variable. If value equals high, motion detected, turn on the relay by sending low to the relay pin and add a 100 millisecond delay. If value equals low, no motion, turn off the relay by sending high to the relay pin and add a 100 millisecond delay. Upload the code to your Arduino. Wave your hand over the sensor, and the bulb will light up. It will remain on for about 3 seconds, as set by the delay, and then turn off automatically. Adjust the sensitivity and time delay potentiometers to modify the sensor's range and delay time. Thank you for watching. We hope you found this tutorial helpful. Stay tuned for more upcoming videos, and we'll see you next time.